is where our master replication comes into play. In this setup, you have two or more bakers who can both make or modify recipes, ensuring that the workload is distributed evenly. So what do? You hire more bakers to help out the primary baker. So in this example, the baker represent your master database. But here is the trick part. Since both database can handle update, they must stay in sync. For example, in a financial system, conflict updates could lead to incorrect amount balance, which could obviously be unacceptable. That is why engineers put a lot of effort into designing replication systems that minimize conflicts and resolve them efficiently. Hey everyone, welcome to Prep10 YouTube channel, where we help you level up your skills and knowledge in backend engineering. I am Sahib Kumar and I'm super excited to have you here today. At Prep10, we are all about learning, growth and practical tips, whether you are a student or just starting out your journey or a budding engineer looking to sharpen your skills. This is the channel all for you. We dive into complex topics and break them down into easy to understand concept and provide you with actionable steps to apply what you learn. Today's topic is the one that plays a crucial role in how modern application functions: database replication. Have you ever wondered how apps like Instagram basically always keep your data updated no matter where you are, or how Netflix ensure that smooth streaming even with millions of users is happening? Well, it's all thanks to database replication. Database replication is the backbone of large-scale apps, ensuring data is synchronized across multiple servers. This makes sure that your experience is seamless whether you are on social media or binge watching your favorite shows. Before we dive deeper into this, make sure to hit the subscribe button and turn on notifications so that you never miss out on content that can help you become a better backend engineer. Also, I would love to invite you to join our Prep10 Telegram community. It's the perfect place to stay updated on latest job and internship opportunities and get career tips or connect with like-minded learners. The link will be in the bio of this channel, so don't miss out. Alright, let me just bring my deck and then we will continue diving deeper into database replication. Alright, let's start with the fundamental concept of database replication. This is the technique that helps keep data synchronized across multiple locations, which ensures availability, performance, and consistency in modern application. Now, to make this more relatable, think about your experience on Instagram. You are scrolling through your feed and it's constantly updating with new posts, photos, stories, and whatnot. But have you ever thought about how this is happening? How does the data stay so fresh no matter which part of the world you are in? This is where database replication comes in. It plays a crucial role in making sure that your data is up to date and synchronized across different servers. Imagine if Instagram did not have replication in place, or your feed would basically show outdated posts and your entire user experience would suffer. This simple process ensures that data is available and consistent for millions of users, and it's vital for large-scale applications like Instagram, Netflix, and Facebook. Replication not only helps you keep data synchronized, but also ensure that application remains fast and reliable. This becomes especially important when we are talking about systems that handle millions of users at the same time. Without replication, this system would struggle to keep up with the demand, leading to slow performance and potential outages. Now that we have introduced the concept of database replication, we will explore the different replication strategies that are commonly used in the industry. But before we dive into the specific, let's think about how replication works behind the scene. As I mentioned earlier, this process is the key to ensuring data availability, performance, and consistency. Alright, so to help you visualize how database replication actually works, let's use a simple example: a bakery. So imagine that you are running a bakery and now you have one baker which is responsible for making all the bread for your customer. It is some kind of magic bread, like the customer loves it. But as your business grows and more customers starts placing orders, it becomes difficult for this one baker to meet the demand. So what do? You hire more bakers to help out the primary baker. So in this example, the baker represent your master database, and the additional baker you hire to help the primary one is the replica database, so often called as slaves. So in a master slave replication setup, the master is responsible for handling all the writes and update to the database, while the slave database are responsible for handling read, just like in the bakery. So the master baker is the one making changes to the recipe, and the other baker just follow along, replicating those changes to ensure that every customer gets the same quality product. Now let's take this example to a step further. What if we want multiple bakers who can both make bread and update the recipe? This is where our master replication comes into play. In this setup, you have two or more bakers who can both make or modify recipes, ensuring that the workload is distributed evenly. However, they have to keep each other in sync. So if one baker updates a recipe, the other baker knows about it. This is the key to ensuring that all customers receive the same product, no matter which baker is making it. The same principles applies in database replication as well. So in master replication, both database can handle read and write, but they must constantly sync with each other to ensure that they have the same data. This setup is great for systems that need high availability and load balancing. Now that we have covered the bakery example, let's dive deeper into master-slave replication and see how it works in practice. Let's now take a closer look at master-slave replication, one of the most common database replication strategy used in the backend system. In this setup, the master database handles all the write and update, so any changes to the data, whether it's adding new information or modifying existing data, are done by the master. Once these changes are made, they are replicated to the slave databases, which are read-only replica of master. This is very useful for applications that experience a lot of read requests but fewer write requests. Think about an e-commerce site where users are constantly browsing product pages. Those are basically read requests, right? But only a few users are adding items to their cart or making purchases at any given time. Those are basically write requests. So by distributing the read request across multiple slave database, the system can handle more users without putting too much strain on the master database. One of the biggest advantage of master slave replication is that it improves the system performance by balancing the load. So the master database does not get overwhelmed with the read request because those are handled by the slave database, and at the same time the slave database are constantly updated with the latest data from the master, so the information users are seeing is always up to date. However, this setup isn't without its challenges. One of the key issues in replication is replication lag, which we will talk about more in detail later. But replication lag occurs when slave database fall behind the master in terms of updates, meaning that the data that they are serving might be slightly out of date. Alright, now that we have covered the master-slave replication, let's move on to master-master replication and see how it differs from this setup. Now that we have covered master-slave replication, let's talk about more complex but highly useful setup known as master-master replication. In this configuration, you have two or more databases that can both handle read and write application. Unlike master slave where only the master handles write, here both database can handle update as they sync with each other continuously. This is particularly useful for systems that require high availability and load balancing. For example, imagine that you are running a global service with users spread across different regions. With master-master replication, you can have one database in Asia, another in North America, and both capable of handling updates and read. And each database can basically serve users in respective region, reducing the latency and improving the user experience. But here is the trick part. Since both database can handle update, they must stay in sync. So if one database is updated, the other must replicate that change immediately to ensure that both database have the same information. However, this leads to a challenge known as conflict resolution. So what happens if both database try to update the same piece of data at the same time? For instance, if two users in different region are updating their profile picture simultaneously, which version will get saved? This is where conflict resolution mechanism come into play. One common approach is the last write wins policy, and where most recent change is the one that gets stored. But this isn't always an ideal case, especially in system where every update is critical. Master-master replication is great for system that need redundancy and fault tolerance. If one database goes down, the other can still handle both read and write, ensuring that the system remains available to users. However, the complexity of keeping everything in sync and resolving conflicts means that this setup requires more careful planning and management than simpler master-slave replication. Alright, now that we have covered the basic of master-slave replication, let's move on to some of the key challenges that engineers face when they start with the replication lag. One of the biggest challenges in database replication is something called as replication lag. So what exactly is this? So it refers to the delay that occurs when a replica database, whether it's a slave or another master, falls behind the primary database in terms of updates. So essentially, the replica isn't just processing changes as quickly as they are being made on the primary database. This can lead to situations where users accessing the replica will see outdated data. Let's go back to a bakery example. So imagine that you are having two bakers working together, but one of them it is a bit slower. So While the faster baker has already moved on to the next batch of bread, the slower baker is still finishing up the previous batch. If a customer receives their order from the slower baker, they will be receiving an older product. This is similar to what happens in a database system when replication lag occurs. Replication lag can be especially problematic in high traffic system where data is updated frequently. For instance, in an e-commerce platform, if there is a lag between master and slave database, a user might see an outdated inventory list or incorrect pricing. This can lead to a poor user experience and even lost sales. So how do engineers deal with this? One approach is to monitor the lag closely and tune the system to reduce it. For example, the replication process can be optimized to ensure that updates are processed as quickly as possible. In some cases, especially for systems that can tolerate a bit of delay, engineers might opt for eventual consistency. This means that while the data might be temporarily out of sync, it will eventually be consistent across all the replicas. This strategy is often used in systems where real-time accuracy isn't critical, but availability and scalability are more important. So now that we have discussed replication lag, let's move on to another major challenge in replication, which is conflict resolution, especially in master-master setup. Okay, let's talk about conflict resolution, which is a crucial aspect of master-master replication. As we discussed earlier, in master-master setup, what actually happens that both database can handle read and write. But what happens when both database try to update the same piece of data at the same time? This is where the conflict arises and conflict resolution become necessary. Let's look at real-world example. So imagine that you are having two users in different part of the world, both trying to update the same profile picture at the same time. One is in, let's say, New York, another one is in Tokyo. Both of these users are making changes to the same record, but since there are two databases, one in North America, one in Asia, both databases are processing these updates independently. Now, which profile picture gets saved? This is a classic case of data conflict. One common approach is resolving this like last write wins. So in this method, whichever update occurs most recently is the one that gets saved. So if the user in Tokyo submitted their update a fraction of a second after the user in New York, then Tokyo update would be the one that sticks. While this method is simple and effective, it's not ideal in every situation, especially when both updates are equally important. Another approach is to use version control or automatic merging. Some system will keep track of different versions of the data and attempt to merge changes automatically. However, this can get very complex, especially when dealing with large data set or frequent updates. Conflict resolution is critical because unresolved conflicts can lead to a data inconsistency, which can break the user experience. For example, in a financial system, conflict updates could lead to incorrect amount balance, which could obviously be unacceptable. That is why engineers put a lot of effort into designing replication systems that minimize conflicts and resolve them efficiently. Now that we have covered the technical aspect of database replication, let's see how it is used in the real world. You might not realize it, but replication is working behind the scene in almost all large-scale applications that you use daily. From streaming services to social media platform, replication ensures that these systems stay fast, reliable, and available to millions of users. Let's start with Netflix. So when you are streaming your favorite shows, you expect the video to load quickly and play without buffering. So no matter where you are in the world, Netflix uses database replication along with a mix of caching to achieve this. By replicating data across multiple regions, Netflix can serve content from the server that is closest to the user, reducing the latency and ensuring a smooth streaming experience. This is especially important for users in different time zone or region where data needs to be available locally to avoid the delay. Next, consider Facebook or Instagram. So every time you post a status update or send a message, that data needs to be available to your friend instantly, no matter where they are. Facebook uses master replication to ensure that data is synchronized across multiple servers in real time. This way, when you post a photo or your friends are in different countries, they can see it right away. So Facebook replication system helps maintain data consistency and availability even with billions of users accessing the platform simultaneously. Finally, let's talk about e-commerce platforms like Amazon. Replication plays a crucial role in making sure that the product information, inventory data, and customer record are always up to date. For example, if a product sells out in one region, the system needs to reflect that change instantly across all the region to prevent overselling. By replicating data across multiple database, e-commerce platform can ensure that their inventory is accurate and the customer gets real-time information about product availability. Now that we have seen how replication is used in real world, let's summarize the key point that we have discussed so much till now and let's see. Alright, let's wrap up everything that we have covered so far in this session on database replication. We started by introducing the concept of replication and why it is important for large scale application. It helps keep data synchronized across multiple locations and ensuring that availability, performance and consistency are always there. We then dove into two of the most common replication strategy, master slave and master master replication. In master slave replication, the master database handles all the write while the slave handle reads, which is significantly improving performance. In contrast, master master replication allows both database to handle read and write, offering high availability and load balancing, but it comes with added complexity of conflict resolution. We also discussed some of the key challenges that engineers face when dealing with replication, such as replication lag, the delay in syncing between the database, and conflict resolution, which occurs when two databases try to update the same data at the same time. Finally, we looked at some real world use cases from companies like Netflix and Facebook, Instagram, Amazon, where replication is essential for ensuring that their services remain fast and reliable and globally available. Thank you so much for watching until the end of this video. I hope this video helped you understand the basics of database replication from master slave to master master and how it all works behind the scene in apps that you use every day. If you found this video helpful, don't forget to give it a like, and it really helps the channel grow and reach more people like you. And if you haven't yet, make sure to subscribe and hit the notification bell so that you don't miss any of our upcoming videos. Also, if you are looking for job or internship opportunities, or if you want to stay updated on latest in backend engineering, join our Prepped Telegram community. We share valuable resources and updates over there as well. More videos on backend engineering are coming soon, so stay tuned. Thanks again for watching, and I will see you in some other video.